Hello friends, welcome to your own channel on data science, artificial intelligence and machine learning. As part of this series on SQL programming, we are learning the applications of SQL and how important it is for data science. So far we have learned DDL, DML, select query, and in this part of the session we will focus on joins. Typically, there are four types of main joins that we have to understand: inner join, full outer join, left outer, and right outer join. Now, what do you mean by inner join? When you say inner join, basically you are joining two tables. One table which is on the left, we call it left, and the other table which we write the syntax, we keep it on the right hand side of the syntax. That is basically the table which is referred first is called the left table, and the table in the join which is referred second is called the right table. So we are trying to join two tables. When you want to join two tables, there has to be a common identifier. Based on common identifier, you will be able to make a join. Now, if you are joining the two tables such that all records, assume there is an ID column with values 1, 2, 3, 4, and there may be other columns in the left table. Similarly, there is an ID column in the right table with values 1, 2, 5, 6. Now you are trying to join these two tables, and when it is an inner join, the common identifiers which are present between both the tables, that is 1 and 2 in this case, only those records are fetched. That is called an inner join. So basically the concept of inner join is simple. Join two tables such that the common identifier present in the both the tables is available in the output table. To make things clear, let's take one example. This is a table animals which has values alphabets A, B, C, D, E, and for each alphabet the table has the animal name. I want to do an inner join with another table thing. So basically in childhood days we would have played the game name place animal thing, right? So I've just taken the two part of that game, animal and thing. So now you're joining the animal table with the thing table on a common identifier which is letter. Now when you join these two tables, you get the output where you see the common identifiers A, B, C are present in the output table. This is called an inner join. Now let's understand full outer join. When you join the two tables such that in the output table you will have all records from both the right table and the left table. So for example, A, B and C are common in both of them. So they are matching, and the values you get here: ant, bat, cat, apple, ball, cap. D and E are present in the left table because in the query when you are going to write, it will be on the left hand side. B and D and E are on the left hand side table available, but the corresponding identifier is not present. So in the output, you get null for the thing. Whereas F and G are present in the right hand side table, but they are not present in the left table. So in the output, the animal column will have the null value. When you are writing a query which will give you such a output, it is called a full outer join. Then you have left outer join and a right outer join. In left outer join, the output will have all records from the left table. And wherever the identifier is available in the right table, in this case ABC, the corresponding values will be picked up. So here you can see apple, ball and cap. Whereas for D and E, the right hand side table does not have the value, so it will be null. In this output, you see F and G are not present here, because here the join is a left outer join. The opposite of left outer join is a right outer join. In a right outer join, all values from the right hand side table will be available in the final output, as you can see here. The common identifiers which are present in the left table, the corresponding values. So you can see that ant, bat, cat is available. And where the identifier is not in the left table, it will be populated null. This is called a right outer join. So we have learned the concept of the four important types of joins: inner join, full outer join, left outer join, right outer join. Let us now see how to write the syntax. So here what we will do, we will create the animal table and populate sample records. Shift Control Enter. I have executed the code. You can pause the video and write the syntax. So select star from animal. It will show the values of the animal table. Now we will create the second table, the right table. So let me run this code. The thing table is what we are creating. Okay. So we have both the tables. Now syntax. So here, see the syntax. From animal join thing. This is what I wanted to refer. This is written on the left hand side and this is written on the right hand side of the join. And that's why we call left and right table. Okay. So here what we say is, from A table we want A dot star, and from B table we want the thing column. If there would have been other columns in B table, we could have written those columns also like this. And if you don't want the other columns, you can restrict the columns which you want. So similarly in A, we can write A dot letter, A dot thing, A dot animal, A dot other column names. Okay, it is not necessary that we choose all the columns. The syntax is simple. From the table, we have given an alias so that we can refer the tables easily. Join second table, we have given the alias. The common identifier on which you want to join is important. You have to specify that. This syntax can also be written something like this. You specify both the tables. Here, instead of using the word join explicitly, you mention the table names and the join condition has been put in the where clause. This query can also be written something like this. You can specify the type of join by saying inner join. By default, if you don't specify the word inner, it means it is the inner join, but it is advisable to explicitly mention the type of join. So this query and this query, both the queries will give you the same output. Let me execute it. So ant, bat, cat, apple, ball, cap. This is exactly the output which I had shown here. This is the inner join output. Let us see the other syntax. This is the second syntax where I have used where condition on the common identifier, which is letter column here. This output matches with the output which we got by the inner join query. Both queries will run equally fast. So whichever syntax you like, you can choose. I prefer explicitly mentioning the join condition. Here, as you can see, I have not specified inner word, but by default, it will still mean inner join. Okay, so we have got the inner join syntax. Let us now see how to go about writing a left outer join. From animal, join, and this time we have to explicitly say left because we are giving importance to the left table. The thing. This is the left outer join syntax, and here you can see D and E values were not present in the thing table, which is on the right hand side. As such, the corresponding values are null. This is exactly shown here as a left join output. You can see A, B, C, D, E are all present in the left table. As such, the output has A, B, C, D, E available. As a quick practice exercise, I would like you to write the right outer join syntax. Pause the video, write the syntax. Okay, I hope you would have written the syntax, and I'm sure the way most of us would do is we would simply take that left query and replace the word left by right and execute this. If you execute this syntax, you see alphabet letters D, E are not coming, F, G are not coming. They are replaced by null. Reason is we wrote the right join syntax. However, we have specified A dot star. The letter column is being picked from the left table, not the right table. As a result, the values for the letter has come null. So the query has to be not this one, but it has to be B dot star A animal. In case you want the sequence to remain as letter, animal, and then thing, then you have to explicitly write the query something like this. So if you write this query, and note this thing is a column and this thing is a table. Don't get confused. Now here A, B, C, F and G. F and G letters are not present in the left table. As such, the corresponding animal name has come null. Okay. Convert this query into a full outer join query. Pause the video. Try to write a full outer join query. Okay. I hope you would have written the syntax of full outer join. Technically speaking, if you use ANSI standard, then this query should have executed properly. If you use Microsoft SQL, PostgreSQL, Oracle, this query would work. Unfortunately, in MySQL, this query does not work. To write a full outer join query, you will have to use left join and right join along with union. So if you write this syntax where you have a left outer join and you have the right outer join, with a union, you will get the desired output. The duplicate entries which you will get because of the left join and right join will be automatically eliminated. So if you run this query, see the output A, B, C, D, E, F, G. All the letters, both from left and right, all the records are present. And this is exactly what was shown here as a full outer join. The reason I'm showing this screen is so you can quickly relate what was the data in the animal table, what was the data in the thing table, and after the join, what is the output. The syntax, once again, pause the video, type the syntax. If you would have replaced this union by the keyword union all, in that case, duplicate entries would come. Let me show the output. Here you can see the union is replaced by union all, and you will end up getting duplicate entries. A is repeating, B is repeating, A and apple is there, A and apple is present, B bat ball, B bat ball. Because of union all, duplicate entries are not eliminated. So when you write a full outer join syntax, the right syntax would be with a union and not union all in my SQL. Great. So we have learned inner join, outer join, left join, right join. Now what I'm going to do, I'm going to add one record in animal table, and I'm going to add one record in thing table. I've executed the syntax. So here you can see one rows affected, one rows affected. So we have made two entries, one entry in the animal table, one entry in the thing table. If you have one entry here, if you do inner join, please remember this record will get joined by this record, and this record will get joined by this record. So you will have the output as B and bat, sorry, the animal is bat, yeah, bat and bus. And this record will get joined by this record, and this will get joined by this record also. So you will have one entry for B, bear and ball, B, bear and bus. Okay. So this is a very important thing that we have to remember while doing the joins. We will discuss more about this when we talk about cardinalities. Okay. For now, let's try to understand some more types of joins. There are two more types of join, semi and anti-join. Now, when you do a semi join, the output required is the records, the identifiers which are present in the left and right table, common identifiers. So here you can see A, B, C. These identifiers A, B, C, B, they are present in both the left and the right table. So all identifier which are matching in the two tables, I want to have in the output table. The condition is the output table should not have the column from the right table. All record should come only from the left table. So basically you have letter column, animal column. These two columns you see in the output, but you don't see the thing column in the output. This is called semi-join. Try to write the syntax for semi-join. You have the output in front of you. Try to write the syntax, pause the video and try to write the syntax. Okay, I hope you would have written the syntax. And I'm sure many of us, the first thing that we would have tried would be take the inner join query, and in inner join query we had written the thing column, remove that, simply keep a dot star from animal inner join b on the column and execute the syntax. But the output we have got a b b bear bat b b bear bat coming 2 times. The reason, in a inner join, this will get joined by this and this will get joined by this, this will get joined by this, this will get joined by this. So you got the entries b bat and b bear multiple times. So what is the right syntax? Okay, the right syntax is to make use of exist clause or use a subquery approach. So here the first syntax you can see is a subquery. What we do is, from the right table we get all the distinct identifiers. In this case the identifier column is letter, so all the distinct letter, and from the left table we see whether those letter are present matching with the letter which are there in the right table. So if you run this query, you will get the desired result. The other approach is use exist. So this syntax, what you are doing is select one. This is just a convention. One is a convention to say true. Yes, it is matching. So one is to say true. So here we have select one from thing as b, where b dot letter equal to a dot letter. Wherever the two letters are matching, it will give you true. And then here we use the exist clause. So for a given record of a, it is checking whether this query returns back true value or false value. So if it returns true, which means the record identifier exists in the another table, those record will get selected. You got the desired result. So two solutions for semi-join. These are the correct queries, and below you have the wrong query, which is inner join. Let me have that wrong query in one screen coming for you. So you can see the correct way of writing semi-join, and you can also see the incorrect usage of an inner join to get a semi-join output. There is another type of join which is called anti-join. In an anti-join, we require the output from the left table where the identifiers are not present in the right table. So here D and E, these two letters are not present in the right table. So I want the output to have only those records. This is opposite of semi-join. The output can be got using, okay, before I show the solution, can you take this as a practice exercise? Pause the video, try to write anti-join query. Okay, I'm sure you would have got the solution. You simply need to change in to not in or exist to not exist. So you have the two queries which are the correct solutions. This is a wrong query. Do not try to use inner join with a not equal to condition. Do not try to get this output. Try to get the output with this correct way. So here, okay, we got the output. We got the same output. Let me execute this one also. And we did not get the desired output. So the right approach, once again, to get the anti-join output, as you can see, the correct queries and the wrong query. Great. Now, the next thing that we have to learn is Cartesian join, cross join. What do you mean by Cartesian join or a cross join? In a Cartesian join, this first record of the left table will join with each record of the right table. Then the second record will join with each record of the right table. This kind of a query where you have the join happening such that each record joins with all the record from other table is called a Cartesian join. So if I have 6 records here and I have 6 records here, I will get an output 6 by 6 equal to 36. Cartesian join you should avoid because the output which you get in most scenario would be not the desired output. Cartesian join is also called as a cross join. The syntax to get a Cartesian join output here is select a dot star b dot star from table, join the another table. Now because there is no common identifier on which I am trying to join, I simply mention on 1 equal to 1. Even this is not required. This 1 equal to 1 I have explicitly written to convey the fact that we are writing a Cartesian join. Even if you remove this and execute the query, you will end up getting a Cartesian join. Let's see how many records. You can see 36 rows returned. This on 1 equal to 1 is like a good practice where you explicitly convey the fact that you intend to do a Cartesian join. So if I run this query, Shift Control Enter, the shortcut to run in MySQL, again you get 36 rows returned. Great. We have learned all the types of joins. The most important joins are inner join, left outer join, full outer, right outer. The sample output is all shown to you. Then there is semi-join, anti-join, and Cartesian join, also called as cross join. Now, when you run all of these join queries, there's another way of looking at these joins. And the other approach of looking at these joins are cardinalities. What do you mean by that? You have a left table, you have a right table. When you are joining the two tables, is the join relationship one to one. For example, in a banking, assuming I'm taking a banking example, there is a customer master table and there is a login table. Login table will have user ID, password corresponding to which customer ID. Customer table will have customer ID and all details of the customer. So common identifier is customer ID, customer ID. And obviously, one customer will have one user ID, login ID, password. So the join between these two tables would be a one-to-one join. Then there's another type of join which is called one-to-many. This is your left table and this is your right table. Example account, you have a savings account, your savings account number. So in account table, you will have many customers. In transaction table, when you do a transaction, the transaction is for which account. So whenever transaction happens, it will have to have a savings account number corresponding to which the transaction is happening. And a given customer can do many transactions. So if you join a account table with a transaction table, you will have one customer having many transactions. This type of join is called one-to-many. Here on the left hand side, we have taken the account table. On the right hand side, we have taken the transaction table. If we flip and keep transaction table on the left hand side and account table on the right hand side, the join would become many to one. Now, the final type of a query, many to many, which ends up like a Cartesian join. If you have two tables which have many to many relationship, for example, there is a student and there is a batch. One student can enroll in many courses, many batches, and a given batch can have many students. If your database design is such that your join ends up being a many to many relationship join, you can be very confident that the database design is incorrect. We have already discussed this concept that when we design a database, many to many relationship has to be managed with a mapper table. If you recollect, a student and a batch has a many to many relationship, and because these relation between student and batch is many to many, which is from a design standpoint, you cannot have this design directly. That's where you introduce a mapper table where between a student to batch mapper table you have one to many relation, and between a batch to batch mapper table you have one to many relationship. And that's where we eliminate this kind of join between two tables. So while writing your SQL queries, if you see there is a many to many join happening between two tables, you can be very confident that the join is a wrong join. There would be very few rare instances. For example, when you are doing deduplication of data. In that case, probably you may end up many to many because you are trying to see whether a given record is matching with multiple many other records, and you may have many to many relationship type of join happening. Otherwise, in most practical scenarios, if your query ends up as a many to many join query, be confident it is a wrong query. Great. Let's just summarize what we have learned. We have learned cardinalities, different types of cardinalities, one to one, one to many, many to one, many to many. And we have learned various types of joins, inner join, full outer join, left outer, right outer, semi, anti, and Cartesian join. I hope you enjoyed the session. In upcoming session, we will discuss functions, and then we will see window functions, which are analytical functions. Till then, thank you. Bye bye. See you in the upcoming session. And kindly do subscribe, share, and like the video.